All right, so that's great. How else can we use this this file to experiment with creating some different meshes? Well, if we go back to our single mesh face command from mesh polygon primitives 3D face, we can start to draw 3D faces that are attached to each other. All right, so I've got 5 faces here. If I join them, right, bring those into the start of the file, we can see that it gives me the anchors at any significant joint, right? These ones that are kind of shallow joints are not being found because I haven't specified anything for the angle tolerance beyond the default. But that's cool. Let's see what that gives us. All right, so I'm going to reset my simulation, let it run, and let's see what we get. Now, this is a way to change the kind of vaulting and volumes that you get from the grid shell based on the primitive inputs. So it's allowing us to create like some more interesting relationships as you move through the space that's created by this grid shell. But it also allows us to, if we turn the control points on, if we start manipulating the control points, right, the simulation has to update. So at this point, if we have an initial kind of sketch that looks like this and we're happy with it, we can start to move these control points around and manipulate it. Now, I guess I just moved it beyond where it could go before it broke. So I'll have to reset and simulate again. All right, so here we're working with not only making a more complex initial state, but we can start to manipulate the initial state to get a different result. I think that's pretty good. I like that one. All right, so I'll pause this and let's address any questions you might have. There's a question about reviewing the color gradient. Right, so what we did is we took the geometry out, which are our points that have been simulated, so they're up in space in the z direction, decomposed them with the point xyz, found the minimum and maximum from math domain bounds of all those values, take the domain apart to get the start and end by domain components, use a color gradient object from params input gradient, and you can specify just one of the defaults for starters. And then use that to shade the simulated mesh input under C. These are the vertex colors, right? So we can shade each vertex, and it will smooth out the shading across the entire collection. All right, so if you have any questions, go ahead and drop any additional questions. Go ahead and drop them into the questions window. While you're doing that, I'll go back through and make sure that I label all the different elements that we added to this file, this being the grid shells file, and we'll address any questions together as a group after that. So this was my gravity factor. Z vector. Unary force. This was the mesh corners. Physical objects, physics engine. This is the point to compose. Bounds. Domain components. Gradient. And there we have it. All right. Now remember that if this is running, we don't have to stick just to shapes that are bound to the C-plane. right, we can start to manipulate the control points of any of these meshes in the Z direction as well, right? And we used just like a simple two-dimensional diagram of what those initial mesh primitives would be. But again, you can start to develop something more three-dimensional as well and still use this strategy for creating grid shells. All right, and one other question we had was about other visualization techniques that you can use, right? Any of the any property that you know about the points that we have at this point, we can use that to color our geometry, right? So if you didn't want it to show a gradient from Z minimum to Z max, you want it to be Y, right? You can use Y to specify the gradient, and now it's shifting in this way. If you wanted to impose a different color strategy onto it, you could definitely do that, right? You could sample all of these points relative to something that's rectangular, like an image, and each one of the points, pixel locations, can be translated to the corresponding mesh here to preview it. Right? And again, you can also do some kind of wonky stuff with the gradient object. There's a kind of zebra pattern, right? So that's in Y or Z. It can be the same in Z, right? Which is actually pretty cool. That's fun. And you know, if you want a finer kind of quality to your mesh, because it's trying to smooth out the difference between all the colors, we block our slider, we set our simulation, and go higher with our mesh divisions. Now remember, this is kind of exponential. It's going to increase dramatically how many mesh divisions we have. And when we're working with it, we want a fast feedback. We want these numbers to be low so that we have a relatively coarse sampling of the mesh. And then when we're ready to do something that requires more fineness, we would then go ahead and increase this number and let it simulate once. All right, so images, different gradients, etc., all possible with the mesh coloration. Okay, we're doing pretty good on time, so we can address one other option for how it would be colored, which would be not based on the mesh, but based on the springs, right? How much they've changed in length. All right, so let's go ahead and do that. I'll save this as grid shells B. Instead of decomposing the points, right, which are kind of locational in nature, if we compare the mesh edges before and after, we can color each one of them so that they get shaded up in a particular way. All right, so let's go ahead and try that, right? I'll just go ahead and disconnect the C here so that we have a simple mesh. And this will be just left as red. But what we want to do is take this mesh and compare their edges, right? So if we go to the Mesh tab under Analysis, Mesh Edges, this allows us to supply a mesh and gives us the edges with one adjacent face, 2, 3, etc. Right? So let's go ahead and take the quad divide all the way from back here and connect that, copy and paste, and the simulated mesh. So now we have these E2 would be all of the internal edges, right? So we have E2 here and E2 there. Now because these meshes are defined in the exact same way, E2, the list item 3, should be the exact same relative edge as E2 list item 3. So what we can do is we can get the length of each one of these edges for E2 by going to curve analysis length, copy and paste. So we have 2, right? So this is the pre-simulated and this is the post-simulated. Let's just get the difference between them. So that's going to be under math operator subtraction. We'll subtract the post-simulation the pre-simulation from the post-simulation, and then take this set of numbers and use them in bounds, gradient. Pull this up here, it's a little bit easier to see. Put my presets back to one of these, like this kind of heat map style. And then we'll custom preview these edges with these colors. So that's under Vector, Color, Custom Preview. So this geometry with this color, make sure I turn all the previews off for all that. Go back, reset, and let the simulation run. Now it's kind of hard to see because we have our mesh edges previewed on, so the lines are being drawn twice. So let's turn the mesh edges off so we just see the springs. And I might even turn the preview off here so we just see the springs. All right. So you can see that as we let it run, there's still kind of a couple of them are bouncing back and forth between kind of yellow and orange. But as we get here, the overall difference, right? The maximum difference is 4 units, and the minimum difference is 1.49. Right? So it actually got a little bit shorter based on where it is in the mesh. But we've essentially reached equilibrium, and the overall difference is not that much. Right? It's a very small percentage. All right. So again, I'll let that play one more time, so we can see at first it's very different across all the different edge lengths. Again, I'm subtracting them, so the ones over here on the bigger faces are going to be more blue. I could also, maybe it's a little bit clearer if I do it as a percentage, so I divide the edge lengths, so I know what percentage of stretch there has been. Set. All right, there we go. Let that run. And they should all start moving towards yellow, I guess, being the average, and red being essentially no change. That's pretty good. All right, that's a really great question. So I'm going to pause that here, and I'm going to zoom around a little bit. It's looking pretty interesting. And again, these are all the internal edges. I didn't include the border edges. Those would just be in E1. All right, good question. Let's move on to the next exercise so we can wrap out the kind of 3 types of simulated systems that we want to work with.